Claxon's Algebra 1 CP class. I am coming at you today to explain how to graph exponential functions. So in order to get down to business here, what I am trying to do is take these graphs. And the first thing I'm going to establish here is that this graph is going to be growing. It's going to be growing at an exponential rate. I know it's going to be growing at an exponential rate because there's a variable right here in the exponent, and this number, also known as the base, that base number, it is greater than 1. So because that's greater than 1, and I have an exponential function because of the variable in the exponent, I know it's going to be growing at an exponential rate. So I'm going to go ahead and show you down here what I want you to do, how I want you to show work for each of these. We already have our Cartesian plane outline, labeled, and scaled. I want to create a table. Okay, and on this table, I want to put X and Y. I'm creating points that I can plot, and then I'm just going to play a game and connect the dots. So the first thing that I want to look at, this value to the negative, we'll say the -4th power. I'll space these out. And then this function at, I can say the function at -2, the function at 0, the function at 2, and we'll say the function at 4, if we can even graph it. You can see here that because of our range, or the way that we defined our y values, you'll find out it makes things kind of difficult on us. So at -4, I know my work, I can make a separate little space here for work. Okay, I know my work is going to be 7 to the -4th power. And we went over that today in class. 7 to the -4 power is the same as 1 over 7 to the 4th. Now, I have to know what 7 to the 4th is, but really, I don't. I just have to know that 7 to the 4th power is going to be a really, really big number. And when I take 1 and divide it by a really, really big number, I know that I'm going to get something very, very close to 0. So in fact, I wouldn't even want to use an equal sign. I just know that this is going to be so close to 0, I'm going to call that about 0. And I know it's going to be a little bit above 0. So at -4, I might want to change the color there. At -4, I want something so close to 0 that it looks like it's touching. Well, it pretty much is going to be touching. Okay, so I just know that's about 0. I'm going to call that about 0. Because for all intents and purposes, it's almost, not quite, but almost. 7 to the -2 power. Well, I know that one's a little bit easier. 1 over 7 squared. I know that 7 squared is 49, so that's 1/49th. I know that 1/50th is going to be about the same as 2/100ths. I know if I double the numerator and denominator, I would get 2/98ths. And I know that 2/98ths is really, really close to 2/100ths. So I can say, hey, this is about, it's going to be a little bit bigger than, but it's about 0.02. See how I did that without even dividing? I used my number sense in order to do that. Now about 0.02. So now it's going to be above that point that I had right there, but still really, really close to 0 nonetheless. Okay? And that's about 0.02. And that's going to be a little bit bigger than that. So we're going to go up here, and we're going to plot that at -2, and just a little bit above that. Well, actually, that looks more like a half, Mr. Claxton. Well, we're just going to keep going. We don't have to get too detailed here. At 0, boy, finally, an easier one. 7 to the 0 power. We know that any number raised to a power of 0 is 1. Makes things a little bit easier on us. And then we have 7 squared. 7 squared, we know, is 49. 49. How do I graph that, Mr. Claxton? Well, you just have to know that that point is going to be way, 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 way up here. In fact, it's going to be above. It's going to be above even this point that I just made. So I know that this function is just going to take off, and that's what we mean when we say it grows exponentially. I know that in between those two, what I could do here is I could say, you know what, I want to calculate 7 to the first now. So I'm going to go back, even though they're not in order. Okay, even though they're not in order, I want to go back and I want to calculate 7 to the first power. Okay, I might even, draw a little arrow. Hey, that should be in between there. I know that 7 to the first power is 7. I'll go ahead and take, 7 to the first power is 7. So, okay, that gives me a lot better feel, Mr. Claxton. So 7 to the, oh yeah, okay, I see what you mean now. You see how this just takes off? We call that growing exponentially. Okay, and it gets over to there. That's not a straight line, by the way. It's more of a curved line. Maybe I can make it a little thicker here to make myself look a little bit more accurate. Okay, it goes through all those, and it should be kind of curvy. Oh, this is really tough to do. Okay, it's going to, okay. Really, that should be, and I know it's going to go forever in this direction. It's going to approach that x-axis, get very, very close to it, but not touch it. Okay? In fact, that looks so poor, I almost don't even want to publish that. But just understand it's going to be real curvy because of what I'm using here. It's really, really, really tough. Okay? It's not a 90-degree angle. And your goal is to do a better job than this. Okay, your goal is to do a better, but you do have to take it through that point 0, 1. Okay, so that's the first one. I'll go ahead and stop now. If you get it, try a couple, and then maybe come back and see the second two completed for you. But that's how you graph an exponential function.